If x is equal to 4 over root 5 plus 1 times the 4th root of 5 plus 1 times the 8th root of 5 plus 1 times the 16th root of 5 plus 1, what is x plus 1 to the power of 48? Now, generally, when we have a bunch of radicals in the denominator, usually the rational thing to do is to multiply both the numerator and the denominator by another rational, preferably a conjugate. I'm going to rewrite root 5 plus 1 as the second root of 5 plus 1. So now we notice something. The 16th root of 5 squared, so the 16th root of 5 squared is equal to the 8th root of 5. Now similarly, the 8th root of 5 squared is equal to the 4th root of 5, and the 4th root of 5 squared is equal to the 2nd root of 5. And so now, we're going to multiply x by the 16th root of 5 minus 1 over the 16th root of 5 minus 1. The reason that I do this is because the 16th root of 5 minus 1 is the conjugate of 16th root of 5 plus 1. Additionally, we can then apply a difference of squares. So let me show you. So the 16th root of 5 plus 1 times 16th root of 5 minus 1 is equal to the 8th root of 5 minus 1. Now, you might begin to notice something. Well, if we multiply the 8th root of 5 minus 1 by the 8th root of 5 plus 1, then we will get the 4th root of 5 minus 1, and so on and so forth. And so we have the 8th root of 5 plus 1 times the 8th root of 5 minus 1 is equal to the 4th root of 5 minus 1. Similarly, the 4th root of 5 plus 1 times the 4th root of 5 minus 1 is equal to root 5 minus 1. Now multiplying the root 5 minus 1 and root 5 plus 1 gives us 4. So finally, root 5 plus 1 times root 5 minus 1 is equal to 4. And so, therefore, x times the 16th root of 5 minus 1 over the 16th root of 5 minus 1 will be equal to 4 over 4 times the 16th root of 5 minus 1. And so this is equal to the 16th root of 5 minus 1 times 4 over 4. And so x is equal to the 16th root of 5 minus 1 because these two cancel out. So now solving for x plus 1 to the power of 48. So we have x plus 1 is equal to the 16th root of 5 minus 1 plus 1, which is equal to the 16th root of 5. And so finally, taking this to the power of 48, so x plus 1 to the power of 48 is equal to the 16th root of 5 to the power of 48, which is equal to 5 to the power of 3, which is equal to 125. And so we are done. Now, this is a special type of telescoping series, often referred to as the cotton candy telescoping series, because it's literally like cotton candy to the brain. It's just so satisfying to watch all of these terms turn into something like 4. Now, in my opinion, telescoping series are one of the most satisfying types of problems in contest math. They're not that common, but whenever they do show up, it's always nice to solve those types of problems. So yeah, thanks for watching. Hopefully you enjoy it, and hopefully I'll see you next time.